The reactivity of the different groups is also kind of periodic. It changes as you go across. So as you start with the alkali metals or group 1, they're very, very reactive. They only have one valence electron, and it's really easy for them to lose it. And the larger they are, the easier it is to lose. Group 2, also very reactive. These two groups are so reactive you will never find them pure in nature. They will always form a salt with a nonmetal because they're so reactive they can't stay pure. They react with everything. The reactivity of the elements in the transition metals, a little less reactive. You can find those pure in nature, and their reactivity kind of plateaus. Then as you approach group 17, our most reactive nonmetals, the reactivity increases again. Except now we're talking about nonmetals, so they're more likely to gain electrons as they become more reactive. It's easier for them to gain a few electrons in order to have a full octet, so that's what nonmetals do. You'll notice I left out group 18 in talking about reactivity because group 18 are the noble gases. They have a stable valence shell. They have a full octet in the cases starting with neon and down, or with helium it has a full valence shell, which is 2. As a result, they're really hard to make react. They don't want to gain, they don't want to lose. If they did anything, they would lose, but they're not going to do either unless you really force them to. They have managed to make radon, xenon, and krypton react in the laboratory setting, and recently also argon, although they don't include that yet in our curriculum. I would be shocked if in my lifetime they ever made helium react, but maybe in your lifetime you'll see an experiment where they were able to make neon react. For the most part, though, you would have to create incredibly specific conditions of very high temperature and pressure in order to make those react, so that would not happen. So those are the least reactive elements on the periodic table, so much so that we call them inert or non-reactive.